So today we're talking about equations with absolute values. The main thing that you have to remember about absolute values is whatever is inside of the absolute value symbols, it means it's that number, it's the distance between that number and zero on a number line. Another way to think about that is whatever number is between the lines is the positive version of that. So the absolute value of negative 3 would be 3. The absolute value of 4 is 4. So you just want to make sure it's positive. And you can only take the absolute value of that number once there is only one single number in between the lines. We don't want an expression in between the lines. We will simplify that and evaluate that and then make a positive. So for number 1, it says evaluate this expression if m is 4. So I'm going to plug in 4. Okay, so I plugged in my numbers, and then I'm going to solve what's inside the absolute value signs first. So it's kind of like parentheses where you solve it first. You need to make sure you do all of the operations first. So 4 plus 6 will give us 10. And notice how I made my absolute value signs. I made them longer than my numbers so it doesn't look like 1,101. Now that I have just one digit in between the lines, I can take the absolute value of it. Absolute value of 10 is 10. Subtract 14. 10 minus 14 is negative 4. That's your answer. So it's okay if your answer is a negative. You just want to make sure whatever number is in between the lines, that becomes positive. So since that minus 14 wasn't an absolute value signs, it's still going to stay minus 14. Number 2, very similar, so I'm going to plug in 2 for x and start solving it. So do absolute value signs first. Do not distribute this negative through. We actually do want to solve what's on the inside first. So 3 negative 4 times 2 is negative 8. And then 3 minus 8 is negative 5. And then we don't want to change the subtraction because it's not in the absolute value sign, so it's going to say minus. Absolute value of negative 5 is 5. 23 minus 5 is 18. Okay, the next part is kind of weird. We're going to be solving actual equations that have absolute value signs in it. And we will actually solve it twice. The reason for that is because let's say we have the absolute value of negative 3. We know the absolute value of negative 3 is 3. But let's say I had the absolute value of positive 3. That's still 3. So notice I can have a negative on the inside or a positive on the inside, and it's still going to give me the same answer of 3. With that in mind, that tells me that for all these equations I'm going to solve twice. I'm going to solve it once when it's normal, just positive, and then I'm going to solve it again if it were negative. So that comes from once positive, once negative. So if I look at number 1, I'm first going to solve it completely normal. F plus 5 equals 17. So to solve this, I would subtract 5 from both sides to get F equals 12. Notice that I got rid of the absolute value signs. So once we're ready to solve the equation, we get rid of those signs and then actually figure out what would F be. So if I plug this in, 12 plus 5 is 17. Absolute value of 17 is 17. Now I said I'm going to solve it twice. The second time I solve it, I want my left side to be negative, and I want the whole left side. So I'm going to put this F plus 5 in parentheses and stick a negative out in front. This allows my whole left side of the equation to be negative, or the opposite. This is like having a negative 1, so I'm going to distribute the negative 1 through to get negative 1F minus 5 equals 17. Add 5 to both sides to get negative 1F equals 22. Then divide both sides by negative 1 to get F equals negative 22. So this is my second answer. So I plug this in, negative 22 plus 5 is negative 17. Absolute value of negative 17 is 17. So it worked. So I'll always solve it twice. The first time, completely normal. The second time, just make the left side negative. Number 2 is a little different. It says the absolute value of b minus 1 equals a negative 3. This negative 3 causes a problem. There is absolutely no time when we can take the absolute value of something and get a negative answer. So if you have a negative right here after the equal sign, it's no solution. It's okay if your answer for the variable is negative like it was here for number 1, but it cannot, the equation itself cannot be set equal to a negative. Let's look at number 3. Just check that 8, make sure it's positive. It is, so I can continue with the problem. So solve it normal. 2t minus 4 equals 8. Add 4 to both sides. To get 2t equals 12, divide both sides by 2 to get t equals 6. Now I'm going to solve it again if the left side were negative, so I'm going to throw a negative out there in front. I keep the parentheses just so that negative gets distributed through each term. So when I distribute that through, I get negative 2t plus 4 equals 8, because that negative changed this negative 4. Subtract 4 from both sides to get negative 2t equals 4. Divide both sides by negative 2 to get t equals negative 2. So those would be my two answers. Number 4, very similar. You want to check to make sure that the number on the right side of the equation is positive, which it is. Then we can go ahead and solve. 3x minus 3 equals 9. Add 3 to both sides to get 3x equals 12. Divide both sides by 3 to get x equals 4. Then solve it again if the left side were negative, and that's really sloppy. Distribute the negative through. Subtract 3 from both sides. Then divide both sides by negative 3 to get x equals negative 2. So again, it's okay for your answer to be negative. You just don't want the right side of the equation itself to be a negative. Moving down, the last two problems are a little bit different. They're different for two reasons. First reason being there's only one variable on the inside of the absolute value signs, no other terms. The other reason is because numbers 1 through 4, they have the absolute value sign by itself on the left. So I need to get this absolute value of h by itself. So if you want to write yourself a note, get the absolute value, which I'm just going to call AV, by itself. So to do that, it's just going to be like if we were getting 2h minus 3 equals 8, getting that variable by itself. So we're going to solve it the same way. Instead of minus 3, add 3 to both sides to get 2 absolute value of h equals 11. Divide both sides by 2 to get absolute value of h equals 5.5. Now that I have the absolute value sign by itself on the left side, I can solve my two equations. So solve it once normal, so h equals 5.5. So that's already solved. I don't need to do anything else there. Then solve it again if it were negative. So it's like this is a negative 1, so divide both sides by negative 1 to get h equals negative 5.5. Which this makes sense because if I had absolute value of 5.5, I get 5.5. If I had absolute value of negative 5.5, I get 5.5. So whenever there's just a variable in between the lines and nothing else, whatever number it's set equal to, this 5.5, is going to be our answer for both solutions, just one's positive and one's negative. Number 6, I need to start by getting that absolute value sign part by itself. So I'm going to get rid of this 4 first. Some people wanted to do 4 minus 3. We can't do that because this has a q, the 4 doesn't. They're not like terms. So subtract 4 from both sides to get negative 3 absolute value of q equals 6. Divide both sides by negative 3 to get absolute value of q equals negative 2. Now that I have the absolute value sign by itself, I want to double check, make sure this isn't a negative. It is. So there's no number I can take the absolute value of and get a negative, so this one will be no solution. And it's because we can't have an absolute value set equal to a negative. I know these are kind of weird, so if you have any questions, please email me.